Hey everyone, welcome to this explainer. Today, we're diving into what is honestly a total game changer for data architecture. We're looking at a concept that takes all that heavy, legacy infrastructure we're used to and completely strips it away in favor of a sleek, relational approach. We are talking about Duck Lake and how it is fundamentally rethinking the modern lakehouse.
But before we get into the nuts and bolts of how this works, I want to ask you a quick question. Really think about it. How much of your daily friction as a data engineer is literally just fighting with complex, bloated dependencies? Now, what if your entire data lakehouse didn't need Hadoop? What if it didn't need Spark at all? If you've ever burned a whole afternoon debugging Java runtime conflicts just to query your own data, this architectural shift is going to feel incredibly refreshing.
Here is our roadmap for today. We'll start by rethinking the modern lakehouse, look at splitting storage and metadata, tackle the small file problem, explore ACID guarantees, and finally, look at the AI control plane. Let's jump right in. Part 1. Rethinking the modern lakehouse. Look, we all know the story. Over the years, traditional data lakehouses have gotten way too heavy. You're practically hacking through a jungle of massive cluster layers just to figure out the state of your own tables. Duck Lake brings a radical simplification to the table. The core paradigm shift here: recognizing that your actual storage and your table's state simply do not have to be tangled up together. It deliberately splits your analytical storage from your metadata management to just streamline the whole shebang. Which brings us to Part 2, splitting storage and metadata. This separation of layers is where the magic really happens. In a traditional setup, checking on a table's state means traversing this insane, complex hierarchy of metadata files sitting out in object storage. It is literally like wandering around a massive, pitch-black warehouse just hoping to bump into one specific clipboard. Duck Lake completely flips this by resolving metadata using indexed SQL queries. So instead of wandering that dark warehouse, you are instantly jumping to the exact aisle in a digital database. It's a night and day difference. In practice, here's how that looks. Your massive analytical Parquet files, they stay right where they belong, out in highly scalable cloud object storage. Your S3, Google Cloud Storage, or Azure. But your metadata catalog, the schemas, the snapshots, the lineage, that all lives in a snappy relational SQL database like Postgres or DuckDB. By isolating those heavy Parquet files in the cloud while keeping the table state in a fast relational database, Duck Lake massively cuts down on query planning latency and those painfully slow object store API calls. Moving on to Part 3, solving the small file problem. Now, let's get real for a second. High-frequency streaming writes, microbatches, usually these operational writes just choke a lakehouse system, right? You end up with a chaotic explosion of tiny files everywhere. Well, Duck Lake tackles this persistent headache with a brilliant technique called data inlining. Basically, it temporarily stores those small data inserts directly inside that relational metadata catalog. This keeps your operational writes lightning fast and perfectly contained.
The workflow is actually super straightforward. Step 1, you buffer those small streaming inserts straight into the relational catalog. Step 2, the system just waits until those records hit a specifically configured size threshold. And Step 3, once you hit that threshold, boom, Duck Lake flushes them all out into a large optimized Parquet file in your object storage. Think of it like a bouncer at a club, keeping folks in a VIP line until there are exactly enough people to efficiently fill a party bus, and then sending them all out at once. It totally prevents that small file chaos.
Part 4. ACID guarantees and simplicity. Now, you might be thinking, wait, if we're decoupling layers and buffering data over here and storing files over there, aren't we sacrificing safety? Actually, no. Duck Lake maintains strict ACID guarantees for all transactions. The secret sauce making this work smoothly is optimistic concurrency control. Because commit operations are really just updating rows in a relational database, rather than trying to rewrite heavy, cumbersome object store files, your transaction conflict windows shrink drastically. Smaller windows mean that if a conflict does happen, the retries are so incredibly light and fast, you avoid system crashes entirely. And this leads us to what is arguably the ultimate breath of fresh air for data engineers, the zero-dependency setup. You can literally bypass all of that legacy infrastructure bloat. I'm talking no complex Spark sessions to babysit, zero Java runtime conflicts ruining your deployments, no heavy Hadoop libraries, and absolutely no need to spin up external catalog services. In fact, the initialization is so lightweight, you can spin it up directly within DuckDB using just a few embedded SQL commands. Literally an install Duck Lake, a load command, and an attached statement pointing to your catalog database. And you've got an enterprise-grade lakehouse up and running. It's almost shockingly simple.
Plus, having this relational foundation unlocks native SQL observability right out of the docs. Since your system catalog is a relational database, those metadata tables are directly queryable. You can just write standard SQL to inspect your snapshot history, check file distributions, and monitor schema evolution. You can even embed data quality rules and rich business definitions right alongside the data itself using simple views and macros.
Finally, part 5, the AI control plane. This shift away from heavy Java cluster layers into clean, relational SQL tables isn't just a massive win for us human developers. It perfectly positions Duck Lake for the next era of development. The big concept here is machine-readable context. By using a relational catalog, you naturally create an ideal semantic control plane for AI agents. It completely bridges the gap between raw storage and autonomous intelligence. Just think about how AI interacts with data. AI coding agents can attach to this catalog effortlessly. They can inspect the metadata natively, sample those Parquet files, infer schemas on the fly, and build analytical views. And they can do all of this without ever having to authenticate into or understand some massive distributed cluster layer. By stripping away that bloated middleware, you've handed AI a direct, incredibly simple interface to work with. So as we wrap up this explainer, I want to leave you with a thought. We spend so much of our time building, maintaining, and honestly just fighting with massive data infrastructure. But considering the approach we've seen today, keeping heavy files in cloud storage, putting metadata in a lightning-fast relational DB, and just dropping the legacy bloat entirely, well, in the era of AI agents and hyper-streamlined workflows, is the absolute best data infrastructure simply the one you barely even notice?